Yes, after J.J. Thomson's atomic model, now we shall discuss about Rutherford's model of an atom. What is Rutherford's alpha scattering experiment? Rutherford allowed a beam of fast moving alpha particles having positive charge to fall on a thin gold foil like this actually. So this is the thin foil and he has allowed a beam of fast moving alpha particles. They are having positive charge to fall on a thin foil. He observed that most of the alpha particles pass through straight line. Most of them are passed through the straight line and some of them were deflected by small angles. See the deflection of some particles and very few particles appeared to rebound. They bounced back. Why? Conclusions. What are the conclusions? What were the conclusions Rutherford alpha scattering experiment showed is most of the space inside an atom is empty. Most of the space inside an atom is empty because most of the alpha particles pass through straight through the gold foil. From that, he has concluded that most of the space inside the atom is actually empty and the atom had a small nucleus having positively charged particles because some of the alpha particles are positively charged, so they were slightly deflected from the small angles. The size of the nucleus will be very small compared to the size of the atom. Because of that, very few alpha particles appear to bounce back, and most of the positive charge and most of the atom is in the nucleus. So what is he saying? While many of the atoms pass through the gold coil, he said that most of the space inside the atom is empty. And he has said that atom has a small space inside the small structure inside it is called as nucleus because and they have positively charged particles were slightly deflected by small angles. That is why positively charged. And he also said that the size of the nucleus is very small when compared to the structure of the size of the atom, and moreover, all the positively charged particles were present inside this nucleus structure. That is why whenever these positively charged alpha particles hit these positively charged particles which are present inside the nucleus, they bounced back. Rutherford's model of an atom. So, from these conclusions, what he has designed the structure, what he has said about the structure model of an atom, let us see. An atom has a positively charged nucleus inside the center, and most of the atom is in the nucleus, and most of the atom will be in the nucleus itself, he is saying. The electrons revolve around the nucleus in different orbits. The electrons revolve around the nucleus in different orbits, as we have seen. The size of the nucleus is very small compared to the size of the atom. Okay, these are all the proposals he has made about the model of the atom. Let us see the defects of Rutherford's model of the atom. Any particle which is moving in the circular orbit would undergo actually acceleration according to physical phenomena, and during this acceleration the charged particle would radiate energy, so the revolving electrons would lose energy and should fall actually into the nucleus, and then what will happen, the atom should blast and the atom would be unstable. We know that atoms are stable. This is the main defect of Rutherford atomic model. Next, we shall see about Bohr's model of an atom. An atom has a positively charged nucleus at its center, as said by the Rutherford, and most of the mass of the atom is in the nucleus. Same proposals. The electrons revolve around the nucleus in specific orbits called discrete orbits. These orbits are called as shells of energy. This is about Bohr model because as Rutherford experiment has got some drawbacks, it would blast if all the electrons if they are falling inside this nucleus, it should blast it get, but we know that atoms are stable. And after that, this Niels Bohr has come into the picture and he is saying some of the proposals made by him. An atom has a positively charged nucleus at its center and the most of the atom is in the nucleus itself. The electrons revolve The electrons revolve around the nucleus in specific orbits called as discrete orbits. These orbits are called shells or energy levels and are represented by the levels as we have seen in that chapter, K, L, M, N, capital letters, and they are also numbered as N1, N2, like that. Okay, see if you see the structure Bohr's model of an atom, see this positively charged nucleus and around this K shell, L shell, M shell, N shell will present. While revolving in the discrete orbits, the electrons do not radiate energy. He is saying while revolving around this orbits, discrete orbits, they do not radiate any energy at all. So they do not have any acceleration, he is saying. Distribution of electrons in different shells. The distribution of electrons in the different shells was suggested by Bohr and Bury. The following are the rules for filling electrons in the different shells. The first rule is the maximum number of electrons in a shell is given by the formula 2n square. That is 2n square, where the n is the number of the shell. The maximum number of electrons which can be fit in that particular shell is given by 2n square, where n is the number of the shell. 1, 2, 3. First shell or K shell can have 2n square. If you take n is equal to 1, then it will be 2 electrons. Second shell, it will be 2 into 2 square, that is 8 electrons. Third shell, so on and so forth. The maximum electrons that can be filled in the outermost shell is 8. Electrons cannot be filled in a shell unless the inner shells are filled. So the valence shell, as we have seen, the shell which is present in the outermost shell is called as valence shell, or is also called as outermost shell. So these outermost shells will get filled up only when the inner shells are filled with electrons. This is what he is saying of the Bohr model. In the next class, we shall see what is the arrangement of electrons.